All right. I think good evening. This is going to be your first one that I would like you to watch before class. This section usually creates a few, you know, it's a little bit of more of a twist, and you got to just kind of control what you're thinking about. So I want you to look at the video, try the play pause it, the little questions, and then we'll certainly have probably a good discussion the next day. So let's bring you up to speed. Today is the discriminant of a quadratic. We have worked hard looking at a quadratic, and if we're given in the standard form, like that, we certainly know that we could complete the square, and we could get x by itself, and we get the roots. The roots are given by that good old quadratic formula, and there's kind of a nice little expression underneath the square root called the discriminant, and that is b squared minus 4ac. Now, a, b, and c are just numbers. So when we plug that in, we're going to get a number. Great, that's what we're in this class for. Well, the nature of those numbers actually tell us a lot about what will the entire expression look like. Let's see if that makes sense a little bit. The expression b squared minus 4ac is called the discriminant. Great. All right, we definitely raised our pay grade. We are no longer minimum wage, but we want to take it up another notch. We will use this symbol. And it's a little triangle, and I'll use it a lot in the notes because it's a lot easier to write than b squared minus 4ac. I sure hope some of you take physics, calculus, so forth. Delta is in different classes, it takes on different meanings. In physics, delta is like a small change. In calculus, it certainly represents a small change. And in math, it represents the discriminant, an expression of putting these numbers together, and it gives you this value. All right, no big deal. All right, well, obviously if I gave you a quadratic and asked you to find the discriminant, all you do is plug in b squared minus 4ac into your calculator, plug in b, plug in a, plug in c, and bam, you have the answer. And you really, if you haven't learned too much, that's not too difficult. So it's pretty powerful in the context of a real life situation. So let's talk about it. There are three possible outcomes of a discriminant. Not numbers, but the idea of positive, negative, or equal to 0. All right. So that discriminant could be positive, could be equal to 0, and less than 0. If we were together in a class, then I would put you in groups and just say, who cares? Well, what if this discriminant is greater than 0? What does that mean to the original quadratic? Very little, a lot, some, could we make a connection? And that's what we're after today. Well, got these great notes for you. If it's greater than 0, then we know the original quadratic has two distinct linear factors. All right, so I may have lost some people with the vocabulary. Hang on. Just trying to give you the fancy stuff right now. If it's equal to 0, which is our personal favorite, my personal favorite, always love it when it equals 0, then we have what we call two identical linear factors, and b squared minus 4ac is less than 0. That quantity underneath the square root is negative. Your mind's thinking, well, square root of a negative number, that's difficult. Yeah, Chuck Norris is pretty good at them, but we call that unable to factorize. But we gotta be able to kind of understand what we're saying. So let's take the next level. Two distinct linear factors means it has two real distinct roots. So remember, roots, x-intercepts, solutions. So maybe geometrically you're kind of seeing what happens. It means that parabola crosses that x-axis in two different spots. Love the equal to 0. So many cool things. It says two identical linear factors. that means it has two identical real roots. How can it hit in one spot twice? Well, you can't be left behind here. And I'll show you a picture here in a second. And then of course, if that's less than 0, then we're trying to take the square root of a negative number. Not that much fun. We just say there's no real roots. All right, picture's worth 1,000 words always. If the discriminant is greater than 0, these are two possible quadratic functions or parabolas that could come out. I don't care if it's going up or down, doesn't matter. These both illustrate the idea that it crosses at two distinct spots. All right, so now when it's equal to 0, look at that quadratic. It's hitting exactly in one spot here and one spot here. What we say in mathematics, when we have a shape that just touches the x-axis, we say it's tangent. Your book will ask you the same question 5 different ways. It will say things like, when is it tangent? That's b squared minus 4ac. When does it just touch the x-axis? That's b squared minus 4ac equal to 0. When does it have a repeated roots? That's b squared minus 4ac equals 0. So it's like you have to take those words and connect it to this or this or this. And finally, to finish this bad boy up, no real roots means it's a parabola. It's got all the rights and privileges of all parabolas, but unfortunately, these do not cross the x-axis. Cool. All right. You're going to get questions that say things like this. Use the discriminant to determine the nature of the roots. So they're not saying what are the roots. That's the biggest problem I have with students is they go, hey, I just did all this work to figure out roots. I'm going to just solve the roots and just say here they are. We don't want you to go that far. Just find the discriminant, determine if it's positive, if it's equal to 0 or negative, and then interpret that. So let's look at this example. First thing you want to make sure is you get it equal to 0. You gotta equal 0. So let me emphasize that real quick. This is important. We need to have it equal 0. Therefore, we can identify our A, our B, and our C. We plug that bad boy in to our discriminant, and we get a crazy number, 12,873, one of my all-time favorites. All we care about, positive, negative, equals 0, which is greater than 0. So I know without a doubt that it will have two real solutions. There are two values, two real numbers that I could plug in for t and make this equation right. Cool. That's it. I know you're shaking your head going, come on. So here, look at this. Ooh, just different number. We subtract, we plug it in. Oh, we got a negative. So in English, we would interpret that as there is no real number that I can plug into this to make this equation work. I can't plug 5 in, -7, whatever. Also, I could say that the graph does not cross the x-axis. All right, not a lot of jobs out there just to find the discriminant. Okay, so maybe there might be a better purpose. So what questions does using the discriminant answer? Well, let's look at a physics question. All right, I throw a watermelon at 125 feet per second. Yeah. Yep. Okay. I'm going to throw it straight up in the air, and it's going to leave my hands at 125 feet per second. Now, you guys have seen those things, those pumpkin cannons and stuff like that. Maybe we're replicating that. And it leaves my hand right at about 7 feet. So as soon as it leaves my hand, gravity starts grabbing onto it, but my force is fighting it, and it's going through the air, and it's like this beautiful watermelon. We have a really nice quadratic equation that represents the height after a given time. And it is this. And I highly recommend you take physics, and because it really kind of shows why and how this equation works. It's pretty cool. G stands for gravity. We'll use 32 feet per second squared. 32 feet per second squared is kind of hard to understand. Think of it this way. It's 32 feet per second. So in other words, if I go to Lake Powell and I'm looking down off a cliff into the water and I jump off into the water, at 0 seconds, I'm traveling down at 0 feet per second. But after 1 second, the acceleration is 32 feet per second. At 1 second, I am now going down towards the water right at 1 second at 32 feet per second. At 2 seconds, I have now increased it by 32 feet, so I am moving at 64 feet per second after 2 seconds, and so on. So that's kind of how that works. VO is the initial velocity, and 7 is the initial height. So I might ask a crazy question like, will that watermelon get up to 50 feet? Well, all I have to do is plug it in. I plug in my G, my VO, my initial height, and the 50. All I have to do now is solve that equation and figure out that t value. But I didn't ask when, I asked will it. And while we're at it, I wonder if it would reach 300 feet. So do you see how it set the same height equation equal to 300? If you're paying attention, you'll know that we just solved those in the previous slide. Those are the equations that I asked you to find the discriminant. So let's check it out. I'll remind you, these are the problems, which are exactly, you're like, where's the 32? Well, 1/2 times 32 equals 16. Let me remind you, we got a positive delta, positive determinant, which is greater than 0. That means we'll have 2 real solutions. In English, then, we go from math world back to the world of people who don't know math. That means the watermelon will be at 50 feet in the air at 2 separate times, 2 distinct times. And the idea there is it's going to pass it going up, and then it's going to pass it going down. However, on this equation, we got the discriminant equal to a negative number, and the translation there is there are no real roots. Well, you can't answer. In this case, we'd say there's no time at which this watermelon would be at 300 feet. And so it's saying that, man, it goes up pretty high, but not 300. I kind of asked the question here is, well, could we look at that quadratic and actually figure out the maximum height? And of course, it's called finding the vertex. We're not going to do that today. Pretty cool, though. You guys know a comedian named Gallagher? Famous for the end of his shows to bring out a watermelon and just smash it in front, and everybody in the first 5 rows just gets crazy. It's crazy. But here we go. All right. So yeah, we're going to step it up a little bit, and that's, I've got 2 examples to talk about. All of a sudden, we're going to start messing with the A, B's, and C's. They're not going to be numbers. There's going to be a variable in there that we can control. And so now here's a quadratic, and it's got this m here, and it's asking kind of a basic question. For what values of m can I control the discriminant so that I always have a repeated root, or I have 2 distinct real roots, or I have no real roots? So this is the type of problems you're going to have tonight. It seems like a lot, but you really have to answer one question and use that to determine the other 2. All right. So first of all, let's make sure we interpret what those are to the discriminant. A repeated root means it's tangent to the x-axis, means it touches in one spot. There we're making delta equal to 0, 2 distinct real roots greater than 0, and no real roots less than 0. Please, first thing you're going to do out of the gate, associate the question to what the discriminant needs to be. All right. So I put number 1 because I want this to be the first thing you do for all the problems. Find where the discriminant equals 0. So I evaluate my A as 1, B is -2, and C is m. I plug it into the discriminant, I work it out, checking my algebra, calling a friend, making sure, and I get when m equals 1. I write think because writing down m equals 1 is not going to help you. You need to sit back and go, all right, what does that mean? All right, when m is equal to 1, that means this discriminant is equal to 0, which tells me that if m is equal to 1 in this, that quadratic will have a repeated root. Whew, that's a lot. And it's so much, I wrote it down. If m equals 1, then the original quadratic will be tangent to the x-axis. It will have one real root. It will have a repeated root. It's going to ask it in so many ways. The more I write this, I think the better off you are. All right, Mr. Sayers, there were other questions that we had to ask. Yes, so first of all, find wherever the discriminant is equal to 0. Now we know m equals 1. Okay, now we're going to find the sign diagram of the discriminant. The sign diagram of the discriminant. Okay. I'm going to fly up here. Okay, in order to make a sign diagram, first mark all the points so the discriminant is equal to 0. Okay, I don't know what a sign diagram, I don't know how to mark points, and then all of a sudden we're on the second step, and I don't even know the first step. So, let's go to the next slide, and hopefully this will work out. All right. Whoa. I just gave myself a mustache, I think. Trying to move that. Can I? Oh yeah, there we go. I'll try to move down here. Let's see if that's a good spot. All right. So I'm going to show you each slide, should show you each step. All right, in order to make a sign diagram, first mark all points where you found the discriminant equals 0. So this is going to be a number line. We found m equals 1. I'm going to make a big dot there. And then that's telling me, hey, when m is equal to 1, the discriminant is equal to 0, and the quadratic has one real root. Sorry, my handwriting with these little pens on the computer. Oh. All right, second step. So this is kind of interesting. You pick any random number in those intervals that are left. So since you just already picked 1, you basically have 2 intervals, here and here. I picked -2 and 3. You could have picked 159, you could have picked -17/3, doesn't matter. Some nice whole numbers works. You could pick 0, that's a beautiful number too. All right, so randomly pick any numbers that you want. You're going to plug those random numbers into the discriminant. Remember the discriminant is b squared minus 4ac, and in this case it was 4 minus 4m. 4 minus 4m. So I plug in the m and I got positive 12 here. I plugged in the 3 and I got -8. I do not care the number. All I care about if it's greater than 0 or less than 0 or whatever. Okay, so you've marked your zeros, you picked random numbers, you plugged them into the discriminant, you've determined if they're positive or negative. Finally, you kind of identify those intervals as positive or negative. So this interval over here, we would just pick we just put a big negative over here, and on this interval we put a big positive over here. And that would indicate any m value over here will result in a positive discriminant, which would give us 2 real roots. So, I don't know. So this is wrong. Sorry, just take the time here to just make sure that's right. I think I can write. So the quadratic has 2 real distinct roots. Sorry. Glad I caught that. All right, when m is greater than 1, then the discriminant is going to be a negative number, so that means it has no real roots. All right, that's a sign diagram. Okay, we are 20 minutes. Just bear with me. We only have one last one. This is the same problem. They change the a, b, and c a little bit. They make a few more variables, but the process is exactly the same. They're asking two distinct real roots, two real roots, a repeated root, no real roots. So they're asking you for a sign diagram. Tell me where, for what values of k will give me these things. All right, same exact process. First thing you want to do is make sure it's equal to 0. Identify your a, b, and c. My a is the everything in front of x squared, so that's k. My b is everything in front of the x, k plus 3. And my c is any constant once it's equal to 0, so -1. All right. First step is to set the discriminant equal to 0 and solve for values to make the discriminant equal to 0. Give you the whole slide here. So b squared minus 4ac, I plug it in, I multiply it out, and then I think to myself, what values of k will make this true? I factored it in this case, and I found -1 and -9 will make the discriminant equal to 0, which makes the original quadratic have one real solution, or we'd say tangent to the x-axis, or repeated roots. All right, slow this down. Sign diagram, it is time. I'll remind you the discriminant, b squared minus 4ac, if you multiply that out a little bit, I think k squared plus 10k is a great thing to use. First step, plot all the points on the line where it equaled 0. So that's my -9 and -1. So my heart and soul means those are kind of like the edges of the intervals. Okay. I picked 3 random points in those intervals. I'm going to plug those into the discriminant and see if I get a positive or negative. I plug in -11, I get a positive. I plug in -3, I get a negative. I plug in +2, I got a positive. Will they always alternate? I'll let you decide. I'll let you decide if you want to prove that it does, or find a situation where it doesn't. So we have now figured out where it's equal to 0. We figured out the intervals, if they're positive or negative. So let's finish this problem. There it is. So this tells us a lot. Remember, we're talking about the discriminant. It is equal to 0 at -1 and -9. The discriminant is positive when k is equal to anything here or anything here, and it's negative. The discriminant is negative if k is any number between here and here. So I'll finally write my final solutions as, if k is equal to -9 or -1, then all that is true. If k is between -9 and -1, then it will have no real roots. Then the discriminant is equal to 0. And finally, if k is in either end, remember that's where we had positive values for the discriminant, then we know it will have 2 real roots. All right. Gosh, I had a lot more. I think that's going to be enough. I think we'll explore it a little bit more in class. I hope that's enough for you to at least start. Please feel free to ask questions during class. We have 90 minutes really to get through this. Some of you will race through it. Some of you will take a little bit to internalize it. Thank you. We'll see you later.